Okay, so what we're going to be doing is we're going to actually demonstrate Ohm's law today. We're going to do a lab, and in this lab you're going to see Ohm's law come out of it. But let me show you a typical circuit. You could have a battery like this, which would kind of look like this, right? And then we would have a resistor, and maybe we took one of these resistors with little stripes on it. Okay. And then, now it could be a light bulb, so you'd actually see something. These little resistors that we just used, that you just figured out the resistance for, all they do is whatever energy is given to them by the electricity, it just radiates it out as heat. It just turns it into the thermal energy, the random motion of molecules of the environment. Okay, now this is kind of awkward to draw. So we're not going to draw batteries like that, and we're not going to draw resistors like this. We have symbols that we use in electrical diagrams that allow us to take shortcuts, and it just makes it easier to draw. But it's like a code, and you just have to know what the symbols are in the code. And the symbol for a battery is this. I think I showed this to you the other day, where this is a long line and a short line, a long line, a short line. And this would be the positive side, and this would be the negative side. And then a resistor, we don't show it as a little, although this would be a perfectly good symbol for a resistor. A little rectangle, that'd be pretty easy to use. But that's not what people chose to use, like decades and decades ago when they kind of figured all this stuff out. Instead, you make a zigzag, like that. And that's the symbol for a resistor. Now there is another symbol I'm going to show you that's not part of this. What if I didn't want the current to flow? I mean, when you don't want current to flow, you can open up the circuit like this. Let me just erase part of the wire. And if you have a gap in it like this, this symbol right here that I just drew, this is the symbol for a switch. So if I pull this thing open, it's now an open circuit, and in open circuits, current doesn't flow, nothing happens. But if I close the switch like that, then current will flow. And I think you saw this right when we did the circuits lab, or I mean where you made your circuits quizzes, right? If the aluminum foil wires weren't connected in a loop, no current flowed, right? So it didn't work. So but this is a symbol for a switch. You can put a switch. There is a switch in the circuit board you're going to be using today. So I could redraw this to make it look prettier, a little more practical. And I'll just leave the switch out of it for now. And there we go. This is my voltage source, some batteries, and this is my resistor R. And of course there's current flowing through it like that. And we say that Ohm's law says this: E equals I times R. And remember, this is voltage. This is current, and this is resistance. Okay. And so what you're going to be doing today, and I'll go up and demonstrate it for you here in a second, we're going to be building a circuit where we have a voltage source, and we have a resistor. And what we're going to do is we're going to measure voltage, and we're going to measure current, and we're going to figure out what the resistance is for it. And we're going to actually arrange this a little bit differently. Okay, so now what we're going to do, though, is we're going to need to measure voltage. How much energy is there in a chunk of charge that goes through it? Now, what have we been using to get voltage so far in the last couple of weeks? What have we used? Huh? We've been using batteries. And batteries are great. But there's a problem with batteries. You can't change what the voltage is with a battery. I mean, here's a battery, right? It's 1.5 volts, and that's what it's going to give you until it wears out. Now, I can double it by getting two batteries and putting them together like this in series, and now I've just doubled the voltage. It's now 3 volts instead of 1.5 volts. But what if I want 4 volts? What if I want exactly 4 volts? Well, I could try to get another battery, but it would be 4.5 volts. What if I want 2 volts? I can't use the battery to get this. But what we have, and what we're going to be using in this lab, is what's called a DC power supply. So the voltage is going to be delivered by what's called a DC power supply. That's the name of the device we're going to use. Now, what does DC mean? Yes. Yeah, and you were robbed. Yes, but I'll give you credit for it anyway. Yeah, it's direct current. Now, what direct current means is that once you close the circuit, the current flows around and around the circuit with a constant direction of flow. So the current doesn't go back and forth. There's this other stuff called AC, right? Alternating current. And that's what we get out of the wall sockets, is alternating current. Well, a DC power supply, which you see one on that table right there, and you're all going to get to use one, is just a kind of an instrument. Okay, it's kind of a boxy looking thing like that. And it's got a couple of digital meters on here. You can see what the current is and what the voltage is. It's got a place where you to put wires that come out like this. Now what you do with this thing is it's got in the back, it's got a cord, and it plugs into the wall. So it's got a wall plug. Now what kind of electricity does it get from the wall? AC. It gets AC. But what it does is that it's got some internal electronics that are not very simple, and we're not going to go into that, and it turns the electricity from AC into DC for us. So that this will be our plus, and this will be our minus. So this wire right here is like the plus side of the battery, and this is like the minus side of the battery, and then we can hook it up to our circuit board. And what we're going to have is we're going to have a circuit board, which I will go over with you. We're going to hook it onto here, and this has got resistors on it, and we're going to measure the resistance, and we're going to not the resistance, we're going to measure the current, we're going to measure the voltage. Make a little data table and graph it and stuff like that. Okay? Now, so this box thing that I've just drawn that you see there on the table, that's going to be our source of voltage. Now on the circuit board are going to be different resistors, and so all we have to do is hook up these wires to these resistors, and we can control what the resistance is, and then we're going to, but we have to measure the current. We also want to measure the voltage that I'm delivering to the resistors. Okay, to measure voltage, we use what's called a voltmeter. Now, voltage is a quantity that changes as you move across something that's in the circuit. Like here's our voltage source. We're going to say that at the negative side, we're going to say that that's 0 volts. That is, the electricity here doesn't have any energy in it. But then when you boost up here, it's going to have some positive voltage. Let's say 5 volts. Now, if I want to measure what the voltage increase is for the DC power supply, what I have to do is put the black lead here and the red lead here on my voltmeter. Here's my voltmeter. A meter, not meter as in length, but a meter as in an instrument that measures something. Okay? So a voltmeter. So you always hook up voltmeters across a circuit element, because what you want to do is measure the voltage change, the change of an energy that's in the electricity as you go across something. Like if I want to know, okay, what's the voltage drop across this resistor? Well, I'd put one of the leads here and one of the leads here, and I'd put my voltmeter like that, across the resistor or across the DC power supply, or across the batteries if I'm using batteries. Okay? Now, something that measures current. Well, what is current measured in? What are the units for current? You remember? Well, see, the units for voltage is volts. The units for resistance is ohms. The unit for current is amps. And so something that measures amperage or current we call an ammeter. And for some reason, I don't understand, they dropped the P. It should be called an amp meter. And if you call it an amp meter, everyone will know what you're talking about. But real snobs out there in the electrical world will kind of snicker at you. He pronounced the P, you know. How naive. Okay, so what you want to do there is you have to measure the current that's actually flowing through the wire. So what you do, let me redraw the circuit here. Here's your DC power supply, which I'll draw with a symbol like that. And then here's my resistor. But then what I have to do is I have to take this wire and put the ammeter, it's called an ammeter. And again, it could be an amp meter. They just dropped the P out of it. I don't know why they did that, but they just do. So you just insert it into the circuit so it goes into the ammeter and out of the ammeter. So the voltmeter, you hook up, you take two wires and you hook it up across the circuit element, and that'll get you the voltage drop across the resistor. But then if you want to measure how much current there is, you have to actually take the wire and put it through, all the current has to flow through the ammeter itself. And it will measure how much current there is. It'll give you a reading for that. Okay? And so what we're going to do is we're going to use a device that can measure both voltage and current at the same time. It's a very cool device. It's called a LabQuest, and I'll show you how to use that in just a minute. Okay. So what you're going to do is I'm going to set up a data table for you, and I'm going to say, and so let's ask a question here now, because I always like labs to answer a question. So here's the question. Okay. what is the relationship between voltage, that should be lowercase v, voltage and current in a simple DC circuit? Okay? Now, so what we're going to do is we want to vary the voltage and see what current we get. And so I'm going to tell you what voltages to use, and then we're going to measure the current for 3 different resistors. Okay, so to answer this question, we need to collect some data. So let's set up the data table first. And then after we set up the data table, we'll do the lab, we'll collect the data, and then we're going to maybe finish it today. We'll analyze the data. And then actually from these data and our analysis of it, out will come Ohm's Law. It'll be kind of cool. So here are the voltages you're going to use. So voltage. We're going to have 0, 0.5, and this is all going to be in volts. 1.0, 1.5, 2.0, 2.5, 3.0, 3.5. Yeah, I'll move it. Thanks. 4.0, 4.5, 5.0. So now we're going to do this 3 times. We're going to really have 3 different trials with 3 different resistors. The first resistor, and we'll definitely check on it. It's going to be a 10 ohm resistor. And what we're going to do for the 10 ohm resistor is we're going to measure the current. So this is all going to be current in amps. Okay. And we're going to do it for a 10 ohm resistor, a 51 ohm resistor, and a 68 ohm resistor. We're going to have 3 different resistors. So we have a lot of data to collect. And hopefully you have a graph paper notebook. If you do, this is pretty easy to do. Pretty easy to make a data table like this. Okay, so what I'm going to do now is I'm going to show you how to set up your lab and with the lab equipment, and then we'll do it, and then we'll collect our data.